In this lesson, we're going to look at how to construct an equation of a line given some certain information. So depending on what information we're going to be given for their question, that will determine which of these forms we're going to use. So on the top slope-intercept form, this is called slope-intercept form because in the equation is the slope, that's m, and the y-intercept, that's b. So if we're given the slope and the y-intercept, we're going to want to use slope-intercept form. On the bottom, we're given point slope form. So if we're given a point and the slope, then we're going to use point slope form. So again, m here is the slope. And then this x1 and y1, that's going to be any point on the line. We can use any of the infinitely many points on the line to put in there. We just need some point on the line. And if we insert those into the equation, that will give us another way to write the line. Now these two things here, though they look different, they're kind of like synonyms. Like I can say trash can or waste basket. They both mean the exact same thing. They're just different ways of saying the same thing. And these two types of equations of lines are really no different than each other. You can take any line and describe them in either way, in either equation. They're just kind of different ways of saying the same thing. And we can actually convert back and forth between the two of them, which we'll learn a little bit about in this lesson. So in this question, we're given the slope m and the y-intercept b. So all we have to do here is take slope-intercept form and just insert m and b. So this is y equals m is negative 2/7, and then b is 3, and that's the equation. If we wanted to graph this, then we would do the y-intercept of 3, and a slope of negative 2/7, so that's down 2, and to the right 7. Then we just draw a line, and there it is. For this one, we are given a point and a slope, so we're going to use point slope form this time. So that's y minus y1 equals the slope m times x minus x1. So remember that x1, y1, that is the coordinate point that's on the line. M is the slope. So again, all we have to do here is insert the pieces. So we have y minus the y value. The y value is negative 3, so we have minus negative 3 here. M is the slope, which is 7/2. And then we get x minus the x value. The x value is 5. So that is an equation of the line. We could simplify this a little bit. Minus negative 3 is the same as plus 3. This would be the slope-intercept form of the equation. Now, if we wanted to, that would be the point-slope form of the equation. If we wanted to change it into slope-intercept form, what we would have to do is we would have to distribute the 7/2 through the parentheses to x minus 5, and then subtract 3 from both sides. You can do that to convert from one form to the other. If we wanted to graph this then from point-slope form, well, this equation tells us a point on the line. So obviously we were given a point on the line, so we know that that's there already. But we could, just looking at the line, say, okay, the x-coordinate is 5, the y-coordinate is negative 3, and the slope is 7/2. So let's find the coordinate point 5, negative 3. And then from there, yep, it wasn't working for a moment. Okay, so from that point, we're going to go up 7 and to the right 2. 1, 2, 3, 4, 5, 6, 7, to the right 2. There's the slope. And then we just draw a line. Alright, now we're given an equation right here. And we're told to find the equation of a line perpendicular to that equation, or perpendicular to that line, that goes through the point negative 3, 1. So slopes that are perpendicular are opposite reciprocal. So we're going to need to take the slope of this line underlined in green, which is right here, negative 7/9, and we need to find the opposite reciprocal of that. If we're looking for a line perpendicular to this line, we need a line that has a slope that is the opposite reciprocal. So again, opposite reciprocal means you switch the sign, that's the opposite part. So this is negative, which means our new slope is going to have to be And then the reciprocal means take the fraction and flip it over. So the slope that we're going to use is 9/7. That is the opposite reciprocal of this -7/9. And it goes through the point -3, 1. So that's the coordinate point that we're going to use. So again, we use point slope form. We do y minus y1. In this case, y1 is 1, so y minus 1. The slope, like we just figured out, is 9/7. And then x minus x1, so we'll do x minus the x value, which is -3. You can simplify this a little bit. Since subtracting a negative is the same thing as adding, we can rewrite the parentheses as x plus 3. So that's the equation. Again, if we wanted to graph this, what we would have to do is find the coordinate point -3, 1, which is right here. From there, use the slope to get a new point. So we go up 9 and to the right 7. 3, 4, 5, 6, 7 is right there. And that's the line. Now for this one, I actually will take this equation here and change it into slope-intercept form. So like I said in the last example, we're going to take the slope and distribute it through the parentheses. So we get 9/7 x plus 3. It may, again, help to think of that as 3 over 1. So 9/7 times 3 over 1, we're going to get 27 over 7. And then on the left, we still have y minus 1. We're not in slope-intercept form yet because we need to have just y equals something, not y minus 1 equals something. So we're going to take that 1 and add it to both sides. So then we get y equals 9/7 x. Then plus, and we got to be careful here, so if we have 27 over 7 plus 1, we go off to the right side and I'll do that real quick. 27 over 7 plus 1. Well, 1 we could rewrite as 7 over 7. Then 27 plus 7, that's going to be 34 over 7. And then that's what we're going to write right here, 34 over 7. So the slope-intercept form would be y equals 9/7 x plus 34/7. And last, we're going to look at if you're just given 2 points and that's it. So we're actually going to use point slope form for this one, but we're going to have to do something first. What we have to do first is we have to find what the slope is. So point slope form means we need a point and a slope. It's not point-point form. So what we're going to have to do is we're going to have to use the slope formula, which if you don't remember, it looks like this. We take the y values and subtract them. We take the x values and subtract them, and then we divide with y on top and x on bottom. So it doesn't matter, again, which one you choose for x1 and which one you choose for x2. As long as your x1, y1 is coming from the same point and your x2, y2 is coming from the same point, it doesn't matter which order you do them in. So let's just say that this is x1, y1, and this is x2, y2. So then it's going to be 10 minus -2 divided by 2 minus 5. Remember that subtracting a negative is the same as adding a positive, so that's going to be 12 on top and -3 on bottom. So the slope is going to be -4. Or again, if you're graphing it, you want to think of it as -4 over 1. That may help. For the equation, though, I'm just going to write -4. All right, so now we've found the slope. It's -4. Then we can use point slope form, which again looks like this. Now you'll notice we have 2 coordinate points, and it actually does not matter at all which one you use. So I'll use the second one. And then the slope, let's see, slope is -4. Then we're going to do -2. So again, you could have used the point 5, -2. Either way of doing that would give you the exact different